Greetings, this is Mr. Caslin. I want to talk about solving similar triangles, and specifically solving similar right triangles using what I call the altitude and leg methods. Alright, so you have a large right triangle. It has an altitude that goes perpendicular down to the base, and what that does is it creates three similar right triangles. This small one, this medium-sized one, and the original right triangle that you started with. Okay, now we could break these apart and find out the corresponding sides and set up proportions, but there's a kind of a shortcut way to think about these problems when you're setting up your proportion. Alright, now notice this 48 here. So they've given us some information, either a number or a variable related to the altitude. Okay, so I'm going to call this an altitude problem. Still writing with my mouse, so my writing's not too good. Okay, notice this large right triangle over here. Here, they don't give us any information about the altitude. What they've done is they've given us information about one of the legs of the right triangle. So we're going to call this a leg problem, and we're going to solve this slightly differently. So let's tackle the altitude problem first. Okay, when you're solving an altitude or leg problem, you're going to set up a proportion. This proportion is a fraction equal to a fraction. Alright, now it's an altitude problem, so you're going to use the altitude as the geometric mean. We talked about the geometric mean as being the two values that you put along this diagonal. Geometric mean goes here and here. Okay. Now in the leg problem, it's going to be the same. Okay, except because this is a leg problem, you're using the information they give you about either this leg or this leg. Okay, and you can use that as your geometric mean. Well, I'll talk about how to handle these square roots here in a little bit, but for now, just trying to figure out what this geometric mean is going to be. Okay, if you don't know what geometric mean is, don't worry about it. It just means the numbers that you fill in on this diagonal, and they're going to be the same. All right, now for an altitude problem, go down your altitude, get to the base of the altitude, and go part and part. Meaning, go this way, figure out what the value is, fill that in. Go this way, fill it in. Okay, I'll do that again. Okay, so go down your altitude, go this way, get that piece, that's x, get this piece, and that's 64. Okay, now you have a proportion. Alright, now you're going to solve the proportion by cross multiplying. So you are going to get a 48x. For those of you who haven't done a, oh, excuse me, Mr. Caslin would help if you did it right. Right? Forget how to cross multiply. Do the butterfly method. 64x is equal to 48 times 48. So 48 squared turns out to be 2,304. Okay, get x by itself, so you're going to divide both sides by 64. Okay, it turns out that when you divide 2,304 divided by 64, you get x is equal to 36. So this piece of your triangle here is equal to 36 units, whatever they didn't give us a unit, so we don't know what those units are. Okay, that's called an altitude problem. Alright, now a leg problem is similar, but remember we use the geometric mean for the leg. Now watch carefully, this is how it's going to differ. On a leg problem, start at the top of your leg and go down to the base. Okay, then you're going to do part and whole. Alright, part means start, so you're at the bottom of your leg along the base. You're going to use this part, which is 11, and you're going to use the whole. Now be careful, this is the tricky part of this problem. What is the distance from here all the way to the end? Well, this segment's 11, this is x. What is it together? Well, it's 11 plus x, or x plus 11. Okay, so you have to watch out for these types of problems. Sometimes they don't give you this piece of it, they give you the whole thing. They'll tell you the whole thing is 25, or whatever it turns out to be. So you use part, the whole, you'd use 11 and 25 in that scenario. Okay, you just have to be careful about what information they're giving you. Oops, excuse me for a second. Let's get our leg back up there to remind us this is the leg problem. Okay, now you're going to cross multiply. A couple tricky things in this problem is, first of all, how do you multiply square roots together? Well, what you want to do is multiply the integer part, 6 times 6, which is 36. Okay, and then square root of 11 times the square root of 11 is the square root of 121, which is a perfect square itself. Turns out to be just 11. So when you do this part of your cross multiplication, you're going to get 36 times 11, 396. Okay, be careful when you do this part of your cross multiplication. You're going to get 11 times 11. We've already said that that's 121 plus 11x. Make sure you're distributing that 11 to both the 11 and the x. All right, now you just clean up this two-step algebra equation, subtract 121 from both sides. That should be pretty easy. 275. So you minus 121 from both sides. And that looks like a 14, only because I can't write very well with this mouse. 121. So it becomes 275 is equal to 11x. And if you divide 275 by 11, I believe that does divide evenly. It divides, you get x is equal to 25. Okay, 25 is the length of this line segment right here. Okay, altitude leg. The big difference is on the altitude, go down to your base and you do part and part. And then on the leg, you do part and whole. Okay. All right. This is a video, so watch it a couple times if you need to. And good luck with your problems.